So, what if I told you we could build a highway to the stars? I mean, no rockets, no giant explosions, just a quiet, smooth ride straight up into space. It sounds wild, right? Well, today we're going to dig into one of the most ambitious engineering projects humanity has ever dreamed up. For our entire history, getting off this rock has always meant one thing: brute force. Seriously, we strap ourselves to a controlled explosion and just blast our way out. It's violent, it's crazy expensive, and honestly, it's super inefficient. But what if? What if there was another way? A better way? A vertical highway? And that's really the big question here. I mean, it's a concept that feels like it was ripped straight out of a science fiction novel, doesn't it? But here's the thing, it's being seriously studied by some of the smartest people on the planet. So could we actually do it? Could we turn this incredible dream into a real, functioning piece of engineering? All right, so to really get our heads around this, we're going to break it down. We'll start with the dream itself, this highway to the stars. Then we'll get into the money side of things, why we need it so bad. After that, we'll look at the anatomy of this crazy machine, piece by piece. We'll also have to face the one huge bottleneck holding the whole thing back. And finally, we'll look at what happens if we pull it off. What does this ultimate unlock mean for humanity? Okay, let's dive right in. First things first, where did this completely wild idea even come from? And what exactly is a space elevator, anyway? So the basic idea is surprisingly simple. Imagine a giant cable, a physical tether that's super, super strong. It stretches from an anchor right here on Earth's surface all the way up 36,000 kilometers to a point in what we call geostationary orbit. Now, up there, things orbit at the exact same speed our planet rotates, so they just hang there, right over one spot. And instead of rockets, we just send up robotic climbers. Think of them as elevators, just climbing this cable up and down, ferrying everything we need into space. And believe it or not, this is not some brand new idea. It was actually first thought up way, way back in the late 1800s by a Russian space pioneer named Konstantin Tsiolkovsky. For a long time, though, it was just theory, just a cool idea. But now, with all our advances in materials science, agencies like NASA are actively studying it. And the verdict is, well, it's theoretically possible, but not quite practical, at least not yet. Okay, so you might be thinking, why go to all this trouble? Why build something so ridiculously huge? Well, the answer, like it is for so many things, comes down to money and access. Because frankly, the way we get to space right now, it's broken. Check this out. Right now, it costs about $10,000 to launch 1 single kilogram of anything into orbit. Just let that sink in. A regular bag of groceries, that costs you 50 grand to send up. It's insane. And that incredible cost is the single biggest wall standing between us and becoming a real spacefaring civilization. Now, a space elevator, it could slash that cost by 99%. We're talking dropping it to maybe $100 a kilogram. All of a sudden, that $50,000 bag of groceries, it costs $500 to send up. That's a game changer. A change that big doesn't just make space cheaper, it completely rewrites the rules for our entire future off this planet. And it's not just about the money, not by a long shot. Rockets pump out tons of chemical pollution. An elevator? It would run on clean, reusable electricity. Rockets are limited by the size of their nose cones, right? You can only fit so much inside. But an elevator could haul up enormous, pre-built structures. We could build things in space that right now are just total fantasy. All right, so the why is pretty clear. It's a no-brainer. But what about the how? I mean, how on Earth, and I mean that literally, do you build something this big? Let's break it down, part by part. So the whole system really boils down to 4 critical parts. You've got your base station here on Earth, the massive cable itself, the little climbers that travel up and down it, and then a giant counterweight way out in space. Every single one of these parts is absolutely essential, and they all have to work together in this perfect, delicate dance. So let's start with component number 1, the Earth anchor. This is the foundation for the whole thing. It would most likely be a huge floating platform out in the ocean, right on the equator. Now, why the equator? Simple. That's where the Earth spins fastest, which gives you the most stability. Plus, it keeps you clear of most big hurricanes and storms. Its job sounds easy, but it's beyond critical. Just hold that cable tight. Next up, we have the heart of the whole system, the mega cable. And look, this is not just some rope. We're talking about a material with an almost unbelievable strength-to-weight ratio. It has to be way, way stouter than steel, but also super light. As of right now, the only things we know of that could even possibly do the job are these exotic materials like carbon nanotubes or graphene. All right, component 3, the climbers. These are basically the cars on our vertical highway. They're robotic pods that would grip the cable and just climb. They wouldn't carry their own fuel or have big engines. Instead, they'd be powered from the ground. One of the coolest ideas is to shoot a powerful laser from the Earth station up to solar panels on the bottom of the climber. That light gets converted directly into the energy it needs to go up. Pretty neat, huh? And finally, the big question. What stops this whole massive thing from just crashing back down to Earth? That would be component 4, the space anchor. This is a huge counterweight. We're talking a big space station or maybe even a captured asteroid that's placed in an orbit way beyond that 36,000 kilometer mark. So as the Earth spins, it flings this counterweight outward. That creates a force, a centrifugal force, that pulls the entire cable perfectly tight. It's just like when you swing a weight on the end of a string. Simple physics on a cosmic scale. So, there you have it. That's the blueprint. It's this incredible dance of physics and engineering. But if it's all figured out, why isn't there one in our skyline right now? Well, because there are some truly massive hurdles to overcome. I mean, think about it. The whole system has to stay in this perfect balance. And space is a dangerous place. You've got high-speed space junk that could slice right through the cable. You've got serious weather, like lightning, that could hit the base station. These are all huge engineering problems that need solving, but there's one problem, one that's bigger than all the others combined. It all comes down to the cable. See, we can make these amazing materials, carbon nanotubes, graphene, in a lab, in tiny, tiny amounts, but we have no way to manufacture them at the sheer scale and perfect quality needed for 36,000-kilometer-long ribbon. This material science problem, that's the billion-dollar bottleneck. Until we crack that nut and can mass produce this stuff, the space elevator is going to stay right where it is, on the drawing board. But hey, let's not end on a downer. Let's dream a little bit. Let's imagine we solve it. We figure out how to make that cable. What kind of future does that open up? What does this vertical highway ultimately unlock for all of us? Honestly, the possibilities are just staggering. Space tourism could become as normal as booking a flight. We could build enormous spinning cities in orbit. Launching satellites, that would become cheap and easy. It would basically be our stepping stone to the rest of the solar system, making missions to the moon, Mars, and everywhere else so much simpler and cheaper. And really, that's the ultimate promise here. This isn't just about a cheaper way to get stuff into orbit. This is the key. The key that could finally turn us into a true multiplanetary spacefaring civilization. We're talking about what could be the single most important infrastructure project in all of human history. So the real question isn't if we should build it, it's when will we finally be able to.